leaves the moon, then it just gets bright very quickly. But you can see it's not a cloud in the sky above the horizon
Wow.
level. So we were really very pleased with that, and we got some beautiful images there. But there's no point in going ahead with that if all the Facebook people can see that. So let's go back to the questions. Let me try unsharing if I can get back to Zoom here. Stop share. There, I see Charles now. I see people.
Yep.
I see it says 35 participants. That's just on Zoom, I guess.
Yeah, then we have, it says it's live streaming on YouTube. For some reason, the Facebook wasn't working, but the YouTube is working. So what I'm going to do is I'm going to post this to Facebook after it's concluded. Then those people can watch at their leisure. Jay, we have a question. It says, there are a number, this is from Andreas. There are a number of solar space missions underway at the moment. Which one is most exciting for you? Which one do you expect the most from?
Well, actually, I just got a message coming in from Aris Vulgaris, just coincidentally. But anyway, ask that question again.
There are a number of solar space missions underway at the moment. Which one is most exciting for you? Which one do you expect the most from?
That's an interesting question, because it turns out that there was a picture posted just today from a new space mission with exceedingly high resolution imaging of the sun and the magnetic field on the sun, of a small area of the sun. So there's just a bunch of stuff going on at the same time. Our alumnus from Williams College, Dan Seaton, now has been working at NOAA, the National Oceanic and Atmospheric Administration, and somebody figured out 10 or 15 years ago that all these weather pictures come from a spacecraft that looks down at the Earth, hovering overhead apparently, but the solar panels are pointing at the sun. So now there are solar telescopes in the solar panels that are simultaneously getting images that are sent down, and we compare those with what we do with the eclipses, and we try to overlap that. And then my colleague Serge Kuchmy in Paris is working with a European group for something called ASPIX, in which they're trying to orbit two spacecraft, excuse me, one of which is far enough away from the other one that it can hover in front or be in front of the view toward the sun long enough to make a much better coronagraph, artificial eclipse, than we can now make. And so we can get to see the corona better from space. And so that's not happening yet for a few years. But there's just a variety of spacecraft that are studying the sun from different aspects. There's one, the Parker Solar Probe, an American spacecraft that's orbiting closer and closer to the sun. And so you can imagine it has a lot of heat shielding on it too. Yeah. And it's actually to sample what the solar corona is directly, pick up the particles. And so I'm hoping for the next few eclipses, we can analyze the line of sight that looks where the Parker Solar Probe is to see what that line of sight looks like, because we'll have a direct sample of the density there. And then the Europeans are about to launch Solar Orbiter. It's been moved to the launch pad now. So there's a whole bunch of spacecraft to study the sun. These are different spacecraft from Hubble, for example, a nighttime spacecraft. You can't point Hubble anywhere near the sun or it would just blow out from the extreme brightness. So there's a whole set of solar spacecraft. There are a number of very interesting ones.
Very nice. Another question. We saw you on a PBS special a few years, this is from a teacher. We saw you on a PBS special a few years back and you were working with students. Were they from Williams also? Do you always work with students when you're on an expedition?
And the answer is yes. I've been on a couple of different public television things, but the most recent was on Nova at the time, PBS Nova at the time of the 2017 eclipse. And I had 8 of our undergraduates from Williams College with me there on Oregon. And so I always do work with students from Williams, way back from my very first eclipse after I became a professor there. I took 4 students with me to an eclipse 10 days after I began as a professor at Williams. And we had 3 of our students, Aaron Meadows and Johnny Inouye and Christian Lockwood, were with me in on our La Higuera center line in Chile last July. So I have Williams College trained since I first came there that if there's an eclipse somewhere in the world, I'm supposed to be there. And
You're predestined for that.
yeah, and
Well, Bet and I
take
laugh.
students, and I like taking students, and I think one of the reasons that they hired me way back is that I had a history of working with students.
And you do it all the time. I love it. Bet and I laugh when we watch the Nova because we're in the bus seat right in back of you and Naomi, and I'm sleeping on that long trip to the annularity, to the path of annularity.
Well, I think you want to start people early because on this trip here, it says Lily Kay on the screen, but her mother, Deborah Pasachoff, who was born on May 8th. So happy birthday, Deborah, coming up.
Oh, very good.
In 1977, in October, there was an eclipse that we saw from a ship. So she was about 6 months old at the time, and she suitably changed her countenance and cried or something when totality came. So she's been observing eclipses from the age of 6 months.
That's great.
A good time to start your
I like
children
that.
and grandchildren on eclipses.
I want to switch
She's
down.
gonna say she's saying something, but she's muted.
Oh, sorry, go ahead.
Well, you're not coming through clearly, Deborah.
Yeah, we got a bad link up.
But
there.
anyway, Jacob and Lily, who were there
Oh,
with her, have each seen
and
2
we
eclipses now.
experienced that again with your grandson, who was a toddler, and the level of okay.
Yeah, we got a bad audio going on with that. We can't understand you. I want to move on to the next question, though.
Okay, I can't understand you, Deborah. If you
Sorry.
type something
Yeah,
out,
Deborah, sorry.
I can see it on the screen and read it, but
Yeah, if you type it on the
audio is
screen,
not coming through.
if you type it in the chat, we could do it that way. Jay,
Or
here's
send
something.
the email.
Here's something that bothered me immensely when I was doing my outreach prior to 2017, the totality then. We have a question from a teacher who obviously did not have a good experience. She says, our school was not allowed to go outside to see the last eclipse, and I felt that my students missed out on something very special. How can we prevent that from happening at the next eclipse? I have my ideas. What are yours?
Well, that is a difficult subject, which I've been working on for a long time. And we worked with the American Astronomical Society. Rick Feinberg had a lot of web stuff about that. We've worked with Canadian optometrist, professor of optometry, Ralph Chu, with the measures of filters and all that. But basically, it's a real problem. There's too much pseudoscience going on. People don't really pay attention to the actual scientific thing. We see that in a number of ways, and we do see that at eclipses where people where people have heard that you go blind during an eclipse, and the implication is that there are special rays coming out of the sun that are different during the eclipse, whereas in fact it's the opposite.
I've heard that.
That the sun is largely blocked. But I do remember we went once, my wife and our 2 then little girls. We went to Williamsburg, Virginia, to see an eclipse. And a partial eclipse, an annular eclipse, and it was cloudy, but we could not persuade the school board to let the kids come out. And anyway, finally we took a last-minute plane and went down to New Orleans and drove a little north to get totality. But but we have this trouble. We've written articles about it. We try to get publicity out for the Great American Eclipse, to use the term that Mike Zeiler has gotten publicized. A lot of us worked in advance to try to give the terms in which you could watch the eclipse safely. Distributed a lot of filters. The group Astronomy Without Borders has collected some millions of those filters that were used during the 2017 eclipse.
Recycling.
When my wife and I went to India for the annular eclipse in December, I took a box of 5,000 filters that we distributed there in Mumbai and Madurai. But we've looked at the statistics. With a big publicity, you don't see the eye injuries that maybe decades ago people knew less. But with the big campaigns we've had, it's been very safe to watch the eclipses, and I wish we could persuade everybody to go out and see them. And we'll have the same task coming up to the 2024 eclipse, especially, that is going across the United States with these partial phases off to the side throughout Mexico and the United States and a lot of Canada.
I had so many teachers write me just before the eclipse saying, "Oh no, my principal just decided." This is now, mind you, this is the Friday before the Monday. "Oh no, my principal just said we have to stay inside. I ordered all these glasses and now we can't go out." And I got lots of letters and emails like that. So I ended up writing a form letter to the superintendents and the principals. And this way I don't want to get the teachers in trouble, because, a teacher can lose his or her job if he argues with the principal a little too much. So I took it on me, and I got some thoughtful responses back from administration. I think they realized what they missed. So I think we might see a little bit more acquiescence to that.
Let us hope. And next time you can also work with the American Astronomical Society, which has not only a website, but Rick Feinberg and other people who are willing to respond on that. And we have written materials that you can show. But it is a problem, especially when it comes up at the last minute, and you have trouble overcoming rumor. It's hard to overcome rumor.
It is. It's amazing. Oh, before my next question, I want to say a special good morning to Rob Lucas. Good morning, Rob.
Oh, there he is.
What time is it out by you? About
it's early in the morning. It's about 6 o'clock right now.
That's what
Okay,
I figured.
well, thanks for waking up for us, Rob. Rob Lucas is in Sydney, Australia, where originally for the let me see if I get the year right, 2002, he was assigned as Sydney University's representative to us when we were in Ceduna, Australia. But he and I have observed quite a number of eclipses together, including last December in India. And then he and I in 2010 were also in India together for an annular eclipse. And so anyway, we've been working on things. I wrote him a note today. He can respond separately about pictures through special spectral lines in the red and the green that are formed only at temperatures of over 1 million degrees, and that were the original way that we discovered that the solar corona really has gas at over 1 million degrees. And I now have a couple of these students, as I mentioned, finishing their senior theses, and we want to use some extra illustrations on the general aspects of that. But anyway, good morning. Good morning, Rob.
Now,
Good morning again.
to the teachers out there, and I speak for them too, because I'm a frustrated science teacher, and this question from another teacher sums it up very nicely. Do you think the new U.S. science standards have made a difference in students' performances? Why do you think we still trail behind other countries' students with our science scores?
Well, I don't really have an answer for that, certainly not any better than Charles Fulco, who's an actual credentialed science teacher, has. There certainly is too much rumor, too much pseudoscience going on, but and I see that now with the current coronavirus, that the MCAS, the Massachusetts standardized tests, have been suspended, but there are these national standards now, and I do recall a story, and they've been around, I forget exactly how long, 15 years maybe, that there was an American astronomer member of the committee, and I forget exactly why she couldn't go to a couple of crucial meetings when they were setting the standards. And so there's no actual astronomy in the standards. And
Yeah, it's
that doesn't
unfortunate.
answer your general question, but it does answer to why there's less astronomy than I wish there were. My wife and I did some junior high school books a few decades ago, and we did put some astronomy in. And in fact, I had the idea that it hadn't occurred to anybody of putting some of the astronomy about stars, especially, in the physical science book and not just the earth science book. Because those junior high school books, there are 3 books: life sciences, earth sciences, and physical sciences. And I tried to spread the background of the astronomy out.
Huh,
But
very nice.
it's a big job for a lot of people to work on.
I can imagine. Liz, on joining us right now, has a question. How big an insult is it to be called a Kuiper Belt object? That's a new way to put it.
So Gerard Kuiper, K-U-I-P-E-R, was a professor of Dutch origin who was for a long time at the University of Chicago, and then wanted a good observing site, so he went and built telescopes out in Texas, in West Texas, with the McDonald Observatory. And he was one of those who figured out that there was a whole set of things out beyond Neptune. They're also called TNOs, trans-Neptunian objects. And somebody worked on them in England, and in England they call it the hyphenated name, including Kuiper. So this is just a kind of thing that includes dwarf planets, which are massive enough to be pulled by gravity to be round, but also some other objects that are not quite as massive and then aren't pulled to be round. And those are all called trans-Neptunian objects or Kuiper belt objects. And there are thousands of them out there, and it just shows that we have better telescopes now than we used to. So it's a very honorable thing. And in fact, I've been involved, started with my fast measuring devices for the solar corona, which we looked for to study the heating of the corona through some very fast oscillations. And working with an old friend of mine, a graduate school friend, Jim Elliott, we started looking about what happens when planets go in front of stars. And then in particular, we moved to Pluto when it was still a planet, and we keep observing when Pluto goes in front of a star. That's called an occultation. Technically, a solar eclipse is an occultation of the sun by the moon. So in any case, we studied Pluto through occultations, which can really pin down where it is. And by the way, the starlight changes. We could tell that Pluto had an atmosphere and study it even before the spacecraft went out. And then in 2017, 2015, NASA's New Horizons spacecraft flew by Pluto, and we got some close-up views of the atmosphere. At the last minute, when my textbook was going to press, the new edition last year. Thank you. When we put an eclipse on the cover. But at the last minute, I worked with Alan Stern, the head of the Pluto mission, NASA's New Horizons mission, to get some Q&A and some details on just what had been found as the spacecraft flew by Pluto with these fabulous images, showing all the structure on Pluto and the atmosphere on Pluto and the layers. And then they wanted something. Well, the spacecraft was still working, 1 meter telescope out in space going out. What do you do? And they got, especially Mark Bowie, images in the general direction that the spacecraft was going out into the Kuiper belt. And they found a few objects and settled on one. which was called MU-69. And we managed, I was part of a team that went to Argentina a few years ago to pinpoint it through an occultation, to try to pinpoint it through an occultation. And there was a subsequent occultation. And then in any case, they reprogrammed the spacecraft. You can imagine what a big deal it is to get NASA to swerve one of its spacecraft to pinpoint its direction. And last January 1st, New Year's Eve, and just after New Year's Eve, the spacecraft flew by this little object, which is a Kuiper Belt object. And it's been given the name now of Arrokoth, A-R-R-O-K-O-T-H. And it turns out to be two little Kuiper Belt objects held that hit each other gradually. And so it's a kind of a figure 8 thing out there. It's only around 35 miles long. And it's been that way since very close to the formation of the solar system 4.5 billion years ago. So now that we can actually study objects in the outer solar system, such as Kuiper Belt objects, we're learning about the origin of our solar system, our baby pictures of the solar system, and it's all very, very interesting and very important.
That's fascinating, but more fascinating is the fact you got a government operation to change its orbit, its direction,
It's a trajectory, yeah.
Its trajectory, rather. Yes, very interesting. We have Chris Curtis from the UK. I'm sorry, he says, I'm from the UK and traveled to witness my first totality with Jay and Mark's group in 2017 in Oregon, and it was a totally clear day, but the skies did not go that dark. What level of sky darkening could we expect for later this year due to the high angle of the sun? I also noticed that it was a very light eclipse from Makanda, Illinois. I think I saw Venus and Jupiter, and I don't think I saw any stars that day. Was it due to the small footprint, relatively small footprint of the shadow of the umbra on the Earth?
Yes, with the light you get in the sky is scattered into the shadow region from further away, and I forget exactly how big the shadow was, but sometimes, especially on these longer eclipses, the shadow is wider. It can be up to a couple of 100 miles wide.
Mm-hmm.
Sometimes it's only 60 or even less. Glenn may know the shadow, or Michael knows the.
I was just going to say, Michael, hold your globe up.
We get this double scattering into the into the path of totality. So it was very clear where we were. He did mention I do have a group with a travel agent, Mark Sood, who I met 25 years ago for an eclipse in India, and he's been running a group for people to come with me to the eclipses. And so this is aside from the scientific side with my students and colleagues. So we do have a lot of different samples, but the sky conditions matter, but the width of the path matters. I don't know. Anybody else here want to add to that?
I believe you have Michael's globe next to you, correct?
Yeah. Oh, that's right. I've got Michael's globe, so I can just take a look here.
Nice hat, Michael. I like that hat. Hold it up closer. All right, I gotta buy me one of them. I like that.
So there's Asia. Let's see. There's Hawaii.
Very nice.
Hawaii, Michael. There's nothing in Hawaii for the next 100 years.
Hawaii had its chance in 1991 and blew it.
And blew it. So, so it left it. Okay.
Is
So
that
anyway,
a technical term, Michael?
That's
Yeah.
right.
So this technically, so whoever suggested the width is right. I don't know if you can see it so well, but the narrow one here is 2017, and the wider one just below it is 2045. And so we can say that some of the sky brightness was the double scattering in during the narrow path in 2017.
Jay, as long as you have the globe, I have a question for Glenn. Glenn, in 1986, I believe you saw 0 seconds of totality from an airplane. Was that correct?
Yeah, that depends on how you measure it, but yes, close to 0
Well,
seconds.
what would that path look like on Michael's globe? Would it actually technically be there as a path, or is it?
I missed the first part of your question. I'm sorry.
Would that path, being it was 0 seconds of totality, would that path exist on Michael's globe?
So it depends if on Michael's globe is on sea level or if it's higher up. This was an annular total eclipse, and the annular segment was very short, a very tiny little narrow horseshoe about 1 kilometer or so across. And as you
Wow.
got up in elevation, higher altitude, that actually sort of shrunk and it get more total like. We never had complete elimination of all the little Bailey's beads, so technically it may not have been total, but we
Huh.
did see a complete ring of chromosphere completely around the sun, and we're able to see the corona around a ring of chromosphere. So
Wow.
it was quite a dramatic and interesting eclipse. The geometry was pretty unique. At least it's unique in our lifetimes and beyond that.
Where did the apex of the cone actually, so did the apex of the cone actually touch the Earth at all, or you had to be in a plane too?
It depends on how you define it in some sense, because if you think about the lunar limb profile, you have all the sort of topography from the mountains and valleys that deviate from a purely smooth moon, and how that projects as you get down to a geometrical point. So they sort of overlap each other. So that's why it's technically not total. So you're not getting this completely smooth transition. You get this kind of irregular kind of stipple transition right at that, what you think is a geometrical point, but it's kind of ragged.
Wow. Well, when Michael was on last week, I'm still wringing my head over the fact that the lunar profile is a polygon. So
Yeah.
I'm still working on that one.
And Glenn used the term annular total eclipse, which is sometimes called a hybrid eclipse. And that just means that the cone of shadow from the moon has a point somewhere, and the Earth rises up, so that if the point is here, it can be an annular eclipse in which the point is above the Earth, but then when it comes in the center part, it's actually hitting the Earth. So the eclipse can be annular, not quite dark enough at the top and the bottom, or one or the other or both, but still be a perfectly good total eclipse in the middle. So we're going to have one like that in 2023. And the totality part just clips the northwestern part of Australia and goes into East Timor. But it's perfectly good totality there, but it is a very narrow path.
Huh. I have a YouTube question.
The 2015 eclipse that went through Gabon, I think, in Africa, I think started
2013.
2013, sorry, 2015 was Saba, thank you. 2013 eclipse, it started in the Atlantic Ocean near the Americas, and then quickly became total and was completely total by the time it hit the coast of Africa.
Yeah, we got clouded out in New York that morning. I was disappointed with a bunch of stalwart 14-year-olds and 15-year-olds on a cloudy morning at 5:30 or it was very early in the morning. Got a question from a YouTuber.
Well, you see, this is a problem we have in New York. Glenn and I have been looking ahead, especially for the May 1st, 2079 eclipse.
Yes, me too.
That's going to be visible in New York and Boston. And there's been some debate. Do you want to go on the Empire State Building or the RCA building, which is where I went as a Bronx High School of Science student to see.
That's a great story.
Sputnik as part of the Moonwash.
Yeah.
As part of the Moonwash team. So and it's close to sunrise there in 2079. So anyway, we're keeping track of that, and that one is on Michael's.
Keep eating your broccoli. Stay healthy. I got a YouTube question for you, Jay. What does studying, and anybody else who wants to chime in too, what does studying the solar corona tell us about the sun? And can you answer this one with a younger audience in mind?
Well, the sun is a ball of gas. In fact, if you go especially for the younger audience, but for anybody, there's a group called You Might Be Giants that had a song, "The sun is a mass of incandescent gas, a great big fiery
Yes, I know
furnace."
that.
Where the temperature is something with a temperature of millions of degrees. So you go to YouTube and just search for that. And gas, as you know, is murky, and you kind of see into it until it gets opaque enough. You can see that on a hazy day. You can sometimes not. It's very sunny where I am now. I can see through a forest across the street. But if it's hazy, I might not be able to see all the way down to the street. So you see through this haze until you can't see anymore. And on the everyday sun, there's a lot of stuff above it, an outer atmosphere, but it's largely transparent until until you get to, it adds up enough to become opaque. And but there is all this other atmosphere here. There's this reddish stuff that appears because of the hydrogen gas, and then there's this beautiful corona that's just so faint that you largely look through it. It's largely transparent. But if you hide the everyday bright sun, then that bright sun doesn't hit the Earth's atmosphere and turn the sky blue, and then we can see the fainter stuff around it. But the corona is only about, during the eclipse, is only about 1/1,000,000th as bright as the everyday sun. It's about as bright as the full moon, so it's perfectly easy to see, but you have to get rid of that blue sky. So basically, the reason we go to solar eclipses is that the moon hides the blue sky, hides the light that makes the sky blue, and then we can see this gas that's already there. And then it was discovered, and it took 70 years before the corona, they got some colored spectra from the corona, but it took 70 years to figure out that it was this weird stuff that was very high temperature gas. And so we've known, and now it's for the last 80 years or so, we've known that the sun is surrounded by this high temperature gas. But there are a lot of stars like the sun. There are billions and trillions of stars like the sun. So we now know that all these stars that are kind of the same temperature range as the sun, 6,000 kelvins or 10,000 Fahrenheit or so, reach a temperature minimum. There's nuclear fusion in the middle, and then the gas is brought out, the energy is brought out, and then there's a temperature minimum, and then the temperature starts going up again when you get outside into what we call the corona. So a lot of my scientific research is related to trying to figure out why the corona gets so hot. Obviously, you have to have some energy injected there, but the corona is pretty transparent, so it's not just light that gets injected there, because the light goes right through. So we're studying different kind of loops on the edge of the sun, seeing how they vibrate and seeing how that might contribute to some oscillation, heating the gas. Maybe there's some little flares going off all the time. And it's an unsolved problem in astrophysics, just how the corona gets heated. Or another way of saying unsolved is that it has been solved. At the moment, there was a paper last year by Steve Cranmer and Amy Weinberger, and they list 17 different solutions that different theoreticians have come out with. So there are 17 different models for what can be doing the heating. So we've been trying to make some observations at eclipses to see vibrations that can tell us which of the models may be favored.
Wow, there's a workshop that could go on for a long time with 17 different talks. Jay, we've got Tara asking, Michael might want to chime in with this too. Can we use the width of the eclipse paths on Michael's maps to estimate the approximate equivalent twilight during upcoming totalities? Wow, that's an interesting question.
Yes.
What do you think, Michael? You're muted.
Okay, the answer is roughly yes, that the darkness of the sky during an eclipse roughly corresponds to the width of the path, but there's another factor, and the other factor is the latitude that the eclipse impinges upon the Earth. So at a very high latitude in the polar regions, the path will naturally be wider, and you'll see, looking at the globe, nearly all the eclipses are quite wide at the polar regions. But if you account for the angle of incidence, then in a direction normal to the sun, then the path isn't that wide. So you won't have quite that degree of darkening because of the path width.
That reminds me that there's actually something going on tonight that some of you people might want to participate in. A woman named Carolyn Kennett from Cornwall in England is setting up the idea that people tonight should just take a photograph of Venus and the moon
Mm,
from all over different places on Earth. And there's something called parallax, and that when you, for example, if I look with one eye and then the other eye, my finger seems to jump across the background. Well, looking from different places on Earth, if the moon is a lot closer than Venus, we could find the distance to Venus. So it's just a long discussion, and she'd like to get all these photographs. The timing is not exactly critical because they can adjust for that. And she thought maybe even a regular camera lens, about a 50 millimeter lens on an ordinary camera would work. So I intend to go out. She says at 9:30 p.m. local time. So I intend to try to go out. I hope it stays clear. 9:30 tonight and take a picture that includes Venus and the moon and send it to her. So you can write me, or you can write eclipse@williams.edu is one of my email addresses. Or you can write her. Her website is https://archaeoastronomycornwall.com. Archaeo, ARCHAEO, astronomy Cornwall, as well as one word.com. And she's going to collect these and try to get a distance to Venus that
oh,
way.
that sounds great.
But
We
it's
also
a fun
noticed
thing
that
to do.
Venus looks very much like a crescent moon these days. So you
Yes.
might, if you have a telescope, it'd be nice to see the crescent moon and the crescent Venus also at the same time. And I want to open it up to anybody now who wants to chime in. Feel free to ask Jay some questions, and if you want to raise your hand, hit the raised hand button, we can let you in. And I know we're running over an hour, but I could talk to Jay all day. So, it's not, anybody have a question here? If not, I got some more from YouTube people. Okay, it says, oh, here's a good one. I
So
think of this too.
Glenn changed his background. He's got a different
Oh, yes.
eclipse behind
His
him now.
totality ended. That was a long one.
Yeah,
Here's a good one I think of often too. When do you think we will return to the moon, if at all? When do you think we will get to Mars?
Those are very interesting questions. As many of you know, the American government and NASA is talking about going back some more manned space. Since the space shuttle ended, we've had to rent space on Russian rockets. And now Jeff Bezos' company, Elon Musk's company are fixing to send people into space. But there's a long tradition that goes back, 50, 60 years maybe. There were people who said, I forget exactly what it was, who lost Russia politically, who politically made the mistakes that led to the Cold War, for example. So I've been kind of saying for a couple of years that in the next year or two, maybe we'll get a TV that will appear from a Chinese astronaut standing on the moon, waving at us. And then people will say, who lost space? And all of a sudden, there'll be a lot of people fixing to put money into NASA's budget to go back with space. We do have a program called Artemis being Apollo's sister, to send people to the moon. The Chinese have a rover around the moon's North Pole. Various countries, India, Israel, tried to land on the moon within the last year. But it's one thing to land an uncrewed rocket on the moon, another to actually land people there. And it depends how big an effort you want to make. I understand that at the time of the Apollo landings, 50 years ago, NASA had 4% of the budget of the United States, whereas now it's a tiny fraction of a percent. And so some of this depends on how much effort and funding you're willing to put into these things.
Oh, Ernie, you better get ready for more animation.
What's going to happen with the
That's how I'm
private
working
people?
on it already.
We'll see whether that works out. Apollo 1 was a disaster with 3 astronauts dying in a fire in a spacecraft, and it took years to recover and public hearings, and Richard Feynman made some interesting things in the public hearing. But we had the backing of the American government for doing this project. But if something should go wrong with Elon Musk's or Jeff Bezos's projects, Blue Origin, I think it's called, is Bezos, and
Mhm.
then I don't know that they'll recover from that. So I think it's not predictable when we'll go back to the.
One thing I always
Now,
talk about.
when I was a graduate student in the 60s and they were about to land on the moon, well, then they landed. Of course, Neil Armstrong and Buzz Aldrin landed on the moon in 1969, just over 50 years ago. Pan Am, an airline that no longer exists, was selling tickets to go up in space, and I think to the moon.
Yes.
I read about that. Yes.
And so we don't have those plans. We don't have that airline. But when I was doing this eclipse expedition, when I first came to Williams, to Prince Edward Island, or to Africa in 1973, we sort of thought at this very distant time in the year 2000, we'd be going up into space and we'd go as tourists to the moon. And clearly now it's 20 years after that, and it hasn't happened, and it's still far from happening.
I remember my mother taking me to see 2001: A Space Odyssey in 1968, and thinking, "Wow, I was counting the years to 2000 so I could, get on one of those rotating satellites and go to Jupiter, perhaps." Got a question for you. I tell my students this all the time. I said, I think the science is there to go to Mars. I think we could theoretically get a manned mission there, but I think people would go crazy. I think they'd actually come back with less than the amount of people you're left with. I think they'd all, the psychology aspect of it to me is the scary part. What do you think about that?
Well, I think if you got volunteers who would move to Mars now and live out the rest of his or her life there, I think you get a number of volunteers.
Wow. I could think of some students I could recommend. No, I didn't say that. Okay.
Of
We
course,
have,
we did have that interesting movie, The Martian, a couple of years ago.
Yes, yes. Wow. Well, I'd love to go on forever, but I have to wrap this up. Anybody have any questions here for Jay? And if not, Ernie, you unmuted. Go ahead.
Jay, I unmuted. Jay, I was just hoping that you could tell us what the spectrum is on your shirt.
Who's talking?
That's Ernie. Ernie Wright.
I don't see you on my screen. Anyway, Ernie Wright, who I don't see on my screen, is one of my favorite people.
He's in Eclipse.
And there he is, in the bottom right.
There we go.
My screen. He is at NASA's Goddard Space Flight Center, where he, among other things, I'm sure, but I know him especially from his work with the Lunar Reconnaissance Orbiter and the very detailed maps of the moon. And so first of all, let me mention that because of this work with the Lunar LRO, Lunar Reconnaissance Orbiter, and a Japanese spacecraft from just before that, Kaguya, we know that we didn't used to know, maybe you did this all with Michael last week, the actual shape and size of the moon. And so we can predict exactly when the Baily's beads are going to be and fix a little more accurately the diameter of the sun that makes the Baily's beads at eclipses. So anyway, one of my favorite historical things took place in 1814 when a young optician named Fraunhofer invented a spectrograph good enough to really spread out the solar spectrum. And he saw, I don't know how close I can get, that there were these dark lines across the spectrum, and he measured 511 of those, which he labeled A, B, C, D up to H. And these are absorption lines. The dark lines are called Fraunhofer lines, and they exist in the spectra of all the stars, including the sun. But at the eclipse of 1868, when there was an eclipse in India, Jules Janssen from France had a decent spectrograph, and he was able to see that there were some bright lines instead of these dark lines that were at the edge of the sun during the eclipse. And he figured out that they were bright enough, maybe he could even see them through the blue sky the next day, which he did. And a few months later, Norman Lockyer from England saw them. And one of those bright lines, with the brightest one, wasn't known until then. And Lockyer and a chemist friend called it helium, because Helios was the sun god and existed only on the sun. And it took 30 years or so before they figured out that helium did exist on Earth. Some geologists got some out of some rocks on the Earth in 1895. So this is from 1868 to 1895. Well, anyway, a year after this eclipse in 1868, William Harkness and Charles A. Young, Americans in an American eclipse, got to see a bright green line, and helium had been a bright yellow line. The bright green line, they said, well, that's coronium. And we all know now that there is a place in the periodic table for helium, but there isn't one for coronium. So coronium did not turn out to be an element. It turned out to be, but it took 70 years for it to turn out to be something that comes out of iron that is heated so hot, it keeps losing electrons as it gets hotter and hotter and hotter. And by the time it gets to 1,000,000 degrees, it can lose 9 electrons or 13 electrons or so. And there's a green line and a red line that come from that, and that were only figured out around 1940.
Did you say Harkness by any chance?
No, I actually, the Harkness house is where they have the summer.
Yeah, I stayed there. Yeah,
festival and-
I thought you said Harkness.
It's
Okay.
Harkness.
Oh, Harkness. Okay, gotcha.
But anyway,
Before
so helium turned out to be a real element, and coronium turned out to be very highly ionized forms of iron. And we do have observations from this last eclipse in the green line and in the so-called the red line from these two
Interesting.
two spectral lines. And then we have there are over a dozen of these spectral lines now from the corona, and now there are some more in the infrared where we didn't just be able to study too well, but the electronics are getting better, and now the wonderful new Daniel K. Inouye Solar Telescope is opening in Hawaii. You may have seen some images taken with some newspapers a month or so ago, but it does also have some corona capability, and it's on a very high mountain, so it's got a position above a lot of the Earth's atmosphere. So there'll be coronal observations, especially in the infrared from that telescope.
Exciting times coming up for observations, both terrestrial and in space. One more thing before we break, Michael just informed me that it looks like the next very short total solar eclipse is 2067 on December 6th, 8 seconds duration. Thank you, Michael. I'm going to keep eating my broccoli.
Well, we've got some kids here. We did earlier. So, I mean, I saw my 9-year-old granddaughter and my 7-year-old grandson, and they may have gone by now, but we have more hope for them seeing the eclipse of 2079. And what was the one you just mentioned?
2067.
2067. There was a British particle physicist, I'm blanking on his name for the moment, who did, Frank Close, had a book a couple of years ago at the time of an eclipse, that when he was in elementary school as a little boy, the teacher told him that in 30 or 40 years there'll be an eclipse that goes, a total eclipse that goes across here, and he really waited. He was really excited by that for a long time. So I think we should be exciting as best we can, as I know many of us here are trying to excite the kids, and maybe they'll get to see an eclipse, or an eclipse will come to them, and or they'll get old enough that they can put it on their priority list to go see.
Jay, the kids born now could actually see the Venus transit in 2117 if they, eat right and stay healthy, which is interesting to think about.
It's, less than 100 years, less than
Yeah.
100 years away.
Jay, I've got to go, but I want to say thank you so much. I would love you to come on again sometime and talk about any other things you'd like to. And that goes for anybody else. Just send me an email. And Thursday's guest, we have a special guest who was at Macanda with me and Vet and my mother and my sister, Sean Herbert from CBS News. He's a CBS News producer. He's also from Portchester, my hometown. And if you've seen CBS News, you've seen Sean's work. He's behind the scenes, but he does great work. And he's got turned on to eclipses in Macanda in 2017. And Steve Hartman, I know, did an On the Road segment He and Sean, we got them to come out, and now we had some converts. So he's going to be my guest on Thursday. So if you have some free time, tune in. I promise it'll be a really good show. Thank you,
Good.
Jay, so much for coming
Well,
on.
thank you very much for inviting me, and thanks to so many friends whose pictures I've been looking at for the last hour.
Yes,
And,
those of you
I
on
look forward
YouTube.
to working with you
Yeah.
all again and seeing you all again. And I hope we can meet each other in person again.
I will. I
Maybe
post
even in
this on.
Argentina in December.
I will post this on Facebook shortly. It's been live on YouTube for the past hour and change as well. So thanks, everybody. I'll see some of you Thursday, and I'll see a lot of you again next week. Take care. Bye-bye.
Okay, so long. Good work, Charles.
Thank you,
Bye.
Jay.
Bye.
Thanks for coming on Science at Home. Appreciate it.
Bye.
Bye-bye.